Okay, so we're going to finish up chapter 10 today. Start off going back and looking at one like we did on Monday. So how do we do the problems on Monday? What pieces of information did I need to know? Yeah, so we need to know our confidence interval or confidence level. So what's the confidence level on this problem? 99. Okay, don't do that yet. You are correct in this situation, but don't do that yet. You'll know why in the next problem. All right. What other information do they give us? Okay, so they give us our standard deviation is 100. So my mean is 50. And my sample size is what? Oh, wait, hold on. The mean isn't 50. The mean is 5,000. The sample's 50. Yeah, I know. And they're like similar type numbers, just with plus arrows. Yeah. All right. Anything else we need, or we got everything we need? Okay. Now, since it's giving me, because remember, we looked at two separate problems on Monday. We looked at ones with mean and we looked at ones with proportions. Proportions didn't give you the standard deviation. Okay, this one does. So now that we have our standard deviation and everything else, we can look back at our Z table and find out what 99% is, which I believe you said was 2.575. So Z is 2.575. So we have everything we need now for this problem. So now we can use our formula for it. Formula was X plus or minus Z times standard deviation over the square root of N. Actually, I should probably put that symbol there. So that was our formula for it. Okay. If you have Desmos up and set up, it should look like that. We're just going to type the numbers in that we just got. So my mean was 50. My Z was 2.575 or 565. No, 575. Standard deviation was, I think it was 100. And we looked at 50 things. Oh, mean was 5,000. That's like something seemed off there. And then there's our two answers. All right, so when you're looking at these problems, the key things is finding the pieces of information we need to plug into that formula. Okay. Do not disturb because I'm tired of it going off. So in this case, my intervals from 4963 point, however many decimal points they want, to 50.36.
So if we're doing a test or if we're doing the like the homework, is it going to ask you how many decimals they want?
It should tell you that, yeah. Yeah, it should tell you how many decimal points they need for it. So normally it's, if they don't, it's typically one more than whatever they give you in the problem. So like in this problem, since they don't have any decimal points, you'd want to go one decimal place. So it'd be 4963.6 and 5036.4. But normally they will tell you how many decimal places they want. All right. So how do you find standard deviation? I know, going way back to the early chapters. So that's if I have a proportion. How did we originally find standard deviation way back when? Huh? We square rooted the variance actually. And how did, okay, so now the next piece of that question, because we're going to work our way back, how do we find variance? Or what was variance? Like, not necessarily how do you find it, what was it? Think about the name variance. What is varying? Yeah, like how far we're away from the mean. Like, so the very first step of standard deviation was taking your data and subtracting it from the mean. That was the very first step you had to do for standard deviation. So if I know my standard deviation, does that mean I should know my mean? Because the only way to find standard deviation is to have the mean, right? Does that make sense? Okay. So if, like in this problem here, they're telling you the standard deviation of the population, then they should already know the mean of the population. And if they know the mean of the population, why go through all this work to find what we think is the mean of the population? Make sense? So while these are important to understand and how to do, and it's a nice way to get you in understanding where to go, the vast majority of situations that you're going to deal with, you will not know the standard deviation. Okay, you will not know the standard deviation of the population because that's something that we don't have that information. Because if we did, we wouldn't have to do all this work. Okay, so in most situations, they're going to be like this, where they don't give you that standard deviation. So we need to have a way to be able to do this without using the population standard deviation. And that's where the next tables come in. Who wants to pass them out? Thank you. So standard deviation tells me how much my bell curve shrinks or like grows, right? The bigger the standard deviation, the wider it is, the smaller the standard deviation, the skinnier it is, right? Yeah. So if I don't know my standard deviation, that piece can vary based on how many numbers I have. So the more data I have, the closer to that normal curve it's going to be. Does anybody remember the number that I said? As long as you have this amount of numbers, you automatically can assume it's normal and you don't have to worry about anything? 30. So the closer you get to 30, the closer it is to that normal bell. So if you look, the red line is 3, and it's spread out a little bit more, right? The green line is 14, and it's getting closer to it. So the closer you get to 30, the closer you're going to get to that black line. Okay? Thank you. The table that I just passed out is known as the t-table. Let's show you how to read it now. So there's a few things. This table is different than your z-table. So your z-table had the z's on the outside and all the probabilities on the inside. There is no probabilities in this table. These are all your t-scores that are in the middle of this table. Okay, so when we're looking for it, it's going to give me my t-score, which we're going to use just like our z-score. Okay, it's just a different way to find that number. If you look on the top, actually, I'm going to tell you, we'll actually do this opposite because it's actually going to be easier this way. If you look on the side, you have that DF, right? Okay. Look at the numbers. It goes 1 through 30, and then they start jumping, right? Because again, once you're over 30, it's basically Z, and you don't need to worry about it. Okay, but they're there in case you get those, because it's a little off. It's not exact. DF stands for degrees of freedom. So your degrees of freedom is always 1 less than your sample. So if I have a sample of 10, my degrees of freedom is 9. It's always going to be 1 less than your n. Okay, so your degrees of freedom is always 1 less than n.
One less than
N,
10 with Nancy.
yes, because n is the sample size. That's the number we've been using for sample size.
Oh, okay. Oh,
So it's always 1 less than whatever your sample size is, which is your n. Across the top, there's 3 different lines. You have cumulative probability, 1 table, and 2 tails. If we're looking at confidence intervals, we're going both directions, correct? So we are looking at 2 tails right now because we're looking in both directions. Next week, when I move into chapter 11, we'll talk about the 1 tail stuff. We're just going one direction. But right now, confidence intervals goes in 2 tails and 2 directions. So we're going to be looking at that last row for the 2 tails. So where is 95% in that last row? Which one of those do you think represents 95%? 0.05. It's just the exact opposite. It's telling you what's left over instead of what's in the middle. So 95% would be the 0.05.
Oh, okay.
Okay. So we're always looking for, in this, we're looking at the 2 tails, and we're going to be looking at that breakdown there. So 90% would be the 0.1 to 0. That'd be 90%.
Oh, okay.
99% would be 0.01. Okay, that makes sense?
Yeah.
Okay. All right. Let's look at a problem, and then we will look at that table on how to find it. All right, so let's look at this problem. Oh, thank you. Let's look at this problem. All right, so a company is looking to increase its productivity and looking at certain stages of the production process and figuring out how long things are taking. Okay. Most things in production are timed to a minute. Like they want things done quickly and efficiently. How many of you, does anybody have anybody that works in like the auto industry, like in like an auto shop? So if you ask them, there's a book that actually will tell you how many hours every job will take. That's how they charge you. Okay. However, if they finish the job in a half hour and it's supposed to take an hour, they still charge you the hour. But now they can get 2 jobs done in that thing and make more money. Okay. So that's where it is. So when you're looking at productivity, you want to set, this is where I'm going to charge you, but I want it done faster because that means I can make more money. The goal is hopefully to make more money for yourself and not the company, and luckily most auto mechanics and stuff can do those type of things and on their own and make some money, which is nice. All right, so in this case, they give you the average completion time of 23.45. So that is my average, which represents my what? That's my mean. So we're still looking for very similar information. That's my mean is 23.45. My sample size is what? 10. So we've got those. My standard deviation. All right. Notice something very different here. It says sample standard deviation. If we look back at the last problem, it says, actually it doesn't say, it just says with the normal based on past experience. But a lot of them will say population standard deviation. So if it says sample, this is where we're using this new table. Okay. And what's my confidence interval or confidence level? 95%. All right. So now we're not going to be looking for our Z. We're going to be looking for our T because of the sample standard deviation. So for my T, I'm going to look at my table. So here's my table. So we are looking at, what is my degrees of freedom for this problem? 9, because it's 10 minus 1. So I'm looking at this row right here. So 10 minus 1 is 9. So we're looking at, on the side, degrees of freedom, we're looking at 9, the DF. Yeah. And then I'm using, it was 95%, right? So it's 0.05. So
What? I thought it was 0.10. No,
95% it said.
that is 95%.
No, we're not looking up here. That'd be 90%.
Oh, got it. Okay, got it.
Yeah, don't look up here.
Yeah, I got it.
What's not 95%? That's the representation of it. And remember, we're looking at the two tail, not the one tail or anything above it. We're just looking at that. We'll talk about the other ones next week. That's my T. Or if you think of it, because honestly, it doesn't make that huge of a difference in terms of our calculations, that's your Z-score. Okay, that's the number we're going to use for Z. Okay. We call it T because it's part of the T table, and the calculations are a little different, but everything after this point is going to be the exact same as we did before. Was it 2.262, right? So that's my T. Do I have everything I need? I have my mean, I have my sample size, I have my standard deviation, and I have my T, which is what my Z was originally. So we go back to Desmos, and I type those numbers in. So 2345.
So your Z would be that.
Yep.
2.262?
Exactly. I'm not going to go through and change my formula and everything else. I'm just going to I'm going to use that as my T. My standard deviation was 4.32. And my sample size was 10.
What's this that you're putting in?
Desmos. You have to type this all in. It's not automatically there. But if you type those two formulas in off the top at the top, it makes your life easy because then you can just change those numbers on the bottom to get your answers.
So the only thing that you did different was just like,
How I found my Z.
okay, so same thing.
Yep. That's actually the only difference between this and what we did on Monday is that number right there and how I find it. So instead of just looking at my Z table and going, oh, that's one of those numbers there, since I don't have my population standard deviation, I have to look for the number there because it varies based on how much information I have.
So you're always taking the Z and minusing it by 1.
Your N minus 1. That's your degrees of freedom. Your N. Oh, wait. Go back.
Yeah, your
Okay.
N, the N.
Yep. That'll give you your degrees of
Minus
freedom.
1.
Yep. Oh, and the top number. Yes.
Right, so then you get your
0.05.
9.
Yes.
Okay.
Okay. That makes sense. Your turn. Yeah, this one. I am on the right screen. Okay, yes, I'm on the right screen. What's my mean? What's my standard deviation? Is it a sample or population? Okay, so I'm looking for T. What's my sample size? And my confidence level is 95. So now we look at my table. So we're looking at degrees of freedom of what? What's my degrees of freedom? 14. It's one less than 50, one less. And then we're going over to the 0.05. So 2.145. And then plug them into Desmos. And we got our answer.
All right, so I'm confused.
Yep.
About, yeah, that part.
Which part?
Like the mean and,
So here, what does it tell you in this problem what the mean is? So the sample mean of 6.4 days.
oh, it says it right there.
Yeah.
I did not read it correctly.
That's okay. Yeah, the problem, so when you're reading the problems, they have to give you your mean if it's looking at a mean type problem. They have to give you your mean, they have to give you a standard deviation. Okay? Or they have to give you the stuff to be able to calculate it, which we'll look at one of those problems later. So they have to give you that information. The question only comes down to is, did they give you the population standard deviation or did they give you the sample standard deviation? Depending on which one they gave you depends on which process you're going to use after that point. But they have to give you those. And they always have to give you your sample size. So those pieces of information they really have to give you in these problems. So when you're looking at it, if they're doing a mean problem, sample standard deviation is T, population standard deviation is Z. Okay. All right. Now let's screw you guys all up. Now we'll mix them all up. Okay, do this one. T or Z? T. Sample standard deviation. Huh? So 60 is my degrees of freedom. And then we're going over to the 0.20 on two tails.
Oh, it's 60.
Yeah.
See, I said I read the 10 gallons,
Oh,
so I did. 10.
gotcha. That will change it. Nine point.
And everything with the T.
So look at
I did.
you got it now.
I did. Because I was looking at just the 80. I was looking at just the 80. I mean, at the, I don't know what, I was looking at 95%
Gotcha. That would change
at
the.
60.
Yeah.
I don't know.
No, if you're looking at 95%, that's definitely going to change that
Yeah.
number. So. So 9.56 to 9.94.
Yep.
So would you be happy going to this gas pump? How much is it supposed to pump out? 10 gallons, right? And I'm 80% confident that it's not. Because 10 gallons is nowhere in between those numbers. Okay. So that's the next thing we're going to start looking at. That's what we're going to go into next week is once we get these values, we're going to be able to take and make some predictions based on what our hypothesis is. So it's called hypothesis testing. So like in this problem, our hypothesis is that the gas pump is pumping out 10 gallons of gas. Based on our data that we've collected here, that's not true. It's pumping out less than 10 gallons of gas. So like we can start to look at those type of calculations.
So when you're doing your problem, can you still put Z as 1.29?
Yeah.
T?
I did here. So that's all I did here. I didn't change it to T.
Mhm.
So all right. Next one. Hold on a second. I'm missing a problem.
What are you doing?
I'm missing a problem. It's okay. It's fine. Do this one. I thought one of my problems got moved, but it's not the end of the world. It's fine.
There's like too many numbers.
There's only one extra number. Z or T? Z. Because population standard deviation. So we're looking for a Z. Look at the very bottom of your T table. There's all your Z's. So what was the Z for 95%? 1.96. The very bottom of your T table will give you the basic Z's that you always use. So you don't need to flip over to that other chart. So when at the final, basically in the other test, you really just need this table for these types of problems. So you'll need the Z for some of the other stuff, but this one has those base ones that we're going to need for this type of confidence intervals and whatnot. Type it into Desmos.
I'm so confused.
Where are you getting confused?
I don't know. I thought like I was starting to do good. I put the X is the 31,100.
Yeah.
The standard deviation is 4,500. The Z is the 95%.
Yeah, which ends up giving you the 1.96.
Right. But then I did. I don't know. I just got so confused.
So the only thing you missed was N.
I didn't know if it was the 250 or if it was the 30.
Well, it says a random sample size of 36. This is where I said at the beginning, the hardest part of this stuff is not necessarily going to be the math. It's reading, because they're all word problems, they're all applications.
So like the 250 has
Nothing to do with this problem. Nope.
anything.
Nope, it's just there. Okay, so you can't, and there's actually going to be certain situations where you can't even, like, they're not going to necessarily give you the number, they'll say 2/3 or things like that. So it's like you have to read it sometimes. You can't just look for numbers and pull them out. Like, you have to understand what the problem's looking for. And that's even more important when we're looking at the process behind it, because you have to know the difference between sample and population standard deviation. So you make sure you have to look for those keywords in there as well.
So the population standard deviation would have to be like that is the
That's Z. Yep, that's Z. All right. Next one. What's this problem asking for? Proportion. That means it's p hat, not mean. This is a proportion. They're not going to give you your standard deviation and your mean because you have to calculate it. So your proportion is just the 220 out of the 500. Basically how you had to figure out your grade a little bit at the beginning of class. You're dividing what you have over the total. So 220 is what we want out of the 500. As soon as you see proportion, realize you're going to have to divide to get that answer. So that's your basically your mean piece, right? And now we need to do our standard deviation. That's the p times 1 minus p over n. Zero, two, two, two. What's my confidence level? Okay. Oh, we need my sample size, which I really did in the other one, so it's 500. T or Z? Proportions are always Z. Because you have your standard deviation. So proportions, you can calculate your standard deviation, so you're always using Z. So in this case, my Z is what? Yep, 1 point what? Yep, 1.96. Now, so you don't have to change your formula in Desmos because in this problem, we already divided by the square root of n, right? We already did that. So we don't want to do divided by the square root of n again. But I don't want you to have to change your formula in Desmos. Because once you have it there, you're going to keep using it. Okay? So my proportion was 0.44. My standard deviation was, or my Z was still 1.96. My standard deviation was 0.0222. For your n, for all proportion problems, if you're going to use this formula, make your n 1. Okay? Here's the reason why. This is a little math. I don't want this down here. Right? I don't want the square root of n down there. Because I already did it. I already did it in my standard deviation. So I don't want to do it again. Okay? So what's the square root of 1? Is 1. When I divide by 1, what happens? It just goes away, right? 5 divided by 1 is still 5. So by putting a 1 there, I in essence get rid of that n. So I don't have to worry about it. So you don't have to go back through and change your formula you're using. So if you're using this formula to do your calculations, because it's a proportion, just set your n to 1 when you're doing your final calculation. Okay? And you'll get the right answer. It's a little trick so you can continue to use the same thing for your problem instead of having to go back and redo other things. Like there's a lot to remember in terms of the maths, in terms of the actual writing side and reading side, that I'm trying to make the calculations as simple as I can for you to make your lives easier. So they interviewed 500 people. They found out 220 registered voters wanted it, which was 44%. So the actual, I'm 95% confident that the actual proportion that's going to vote for the candidate would be somewhere between 0.396 and 0.483 or 0.484. So somewhere from between basically 40 and 48% would actually vote for the guy. Yes.
Why would you do a confidence interval if you can just find the proportion?
Because the proportion isn't for the population, the proportion's for that sample.
Oh, okay.
So the
So-
confidence interval is basically telling me,
For the population.
right, is what's going to happen in the general population. So this is why those polls always say like plus or minus 3%, because it's giving you that range. Because like they did a couple samples of 1,000 people, they know this is about what's going to happen based on that. But in the general population, it has that range. That's where the confidence interval comes into play. All right. So to do a problem, what do I need? So I need mean, I need standard deviation, my confidence interval, my sample size, right? Unless it's a proportion. Is this a proportion problem or a mean problem? This is a mean problem because it's talking about average, right? So this is a mean problem. Okay, so I need mean, standard deviation, sample size, and confidence interval. Okay. So do they give that to me?
Yeah.
Okay. What do they give me?
$2 billion a year.
Is that what?
That's what's the total.
Right, but that's not going to be, I need mean, standard deviation, and the sample size. Let's start off easy. What's the sample size? Huh? 10. And there's also 10 numbers here. So that's your sample. So yes, they give you that, and that, but none of those are about the sample. Those are about the population. Okay, so none of those are about the sample. So we can't use those in this situation. Okay, so we need our mean and our standard deviation, but they gave me a bunch of numbers. So we have to use one of those online calculators to find my standard deviation, because remember I told you you're not going to have to calculate it out yourself. So go to Google, type in standard deviation calculator, and you can find one. So I can type the numbers in because I closed the freaking tab with them on it. It's what happens when I clean up my tabs after class. I use calculator.net. That's the one I've been using.
Please?
Calculator.net. That's what I told you about at the beginning of class. But if you type in Google, just type in standard deviation calculator, it should be one of the first ones that comes up. I'll flip over as soon as I type in the numbers. So this is calculator.net. Statistics calculator. You type your numbers in, you hit calculate.
So we type in,
Those 10 values. Five. So you type those 10 numbers in. The nice thing is this calculator also gives you the mean, so you don't have to calculate your mean separately. You get a mean of 8051.5, so 805150. And this calculator is going to give you two standard deviations. Which one do I need? Sample one. It's going to give you your regular standard deviation, and it's going to give you your sample standard deviation. This is a sample. This is not a population. So we need to use the sample standard deviation. Okay. So 1783.55 is my sample standard deviation. Huh? So depending on the calculator you use, it should have had a button that you could have picked population or sample. Yeah, there was two of them on the site. So depending on which one you use on here.
you said use population?
Yes. So if you use this one, you have to make sure you click sample. So yeah, where what?
These two numbers, I get 10 numbers in here.
Make sure you put a comma between them. Yeah, you have to put a comma between them. So you do this one, same concept. They'll give you the standard deviation just because you clicked what it was. It'll only give you the one. Yes, it does auto click population. So you have to make sure you don't use the population.
Standard deviation. Okay.
And your mean should also be there.
Yep.
All right, so now that we've got our information, I need a 90% confidence interval. So 90%. Are we using a Z or a T? Why is it T? Correct. So we have a sample. That's the only difference, right?
Yeah.
Do you have the population standard deviation or did we find the sample standard deviation?
I just got standard deviation.
Right. But did you find that of every single possible funeral in the entire country or did you find it for the sample of 10 numbers that are on your screen? Right. So it's a sample standard deviation. That's the difference. So this is a sample standard deviation, so we're using T. So it's 90%. And what's my degrees of freedom? .90, so we're using the 0.10. So it should be 1.833.
So where do you? I got a, what? I got a different standard deviation.
Then when you typed it in, you hit population. So
Oh, and it should be sample?
yes. So which screen did you have? Does it look like this? Or does it look like
That's
this?
different. That's different. Okay. All right.
Does it look like this one?
Um,
These are the two from calculator.net, so it depends on which one you picked.
It says standard deviation calculator. It's calculator.
Okay. So it's this one.
Yeah.
Okay. Scroll down. So you don't have to type your numbers back in.
Yeah.
Yeah. And then you got the number.
Yeah.
Okay. All right. So type those in. Let me make sure I get the right numbers. Oh, 178355.
So what was it? 90.
90%.
One, 1833.
Yep. So degrees of freedom of 10 or 9. Then you're going over to 0.10. Because that's 90%.
Right, but I don't see where we're getting.
So 9 and 0.10 is 1.833.
Oh, not.
Remember, degrees of freedom is always one less to what?
Where'd you get the 10? Oh, the 10. I got it.
Yep.
So the X is the 8051.5.
All right. So are you confident enough to say that the cost of the average funeral in this suburb is higher than the national average?
Yeah,
Why?
only 9,000,
Okay.
bottom only 7,000, which is only 100 less than. Yeah.
Okay. Anybody else? Everybody agree with that? Okay. The answer is no. What does a confidence interval tell you? How many means are there? There's only one mean, right? Yeah. So when I'm getting my confidence interval, it's telling me that I'm, in this case, 90% confident that my mean is somewhere between 7017 and 9085. Okay? I don't know where it is. It's somewhere in there, though. Because 70-17 is below the national average, my mean could be below the national average. Okay. I don't know where it is in that thing. I'm 90% confident it's somewhere between those two, but you can't go, oh, I'm going to split it in the middle and go it's 45% higher. It doesn't work that way. The confidence interval just says that it's somewhere between those two numbers. And if it could be below, then I'm not confident that it's not. So the data that as it states would say that I don't have enough information to determine if it's higher or lower. If I did a lower confidence interval, it could pop it up. So, but then I'd only be 80% or 70% or whatever else confident that that's true. So, well, yes, but I'd be less confident in my statement. So, and in all honesty, that's how some people play games with their numbers. They'll get an answer and it's like, oh, I don't like that answer. What can I do to change it so that I like my answer? And that's one of the methods that they use. They will lower their confidence level. Okay. So that's why one of the last things we're going to do is I'm actually going to find a couple actually research it, and I'm going to show you like where they actually say this stuff. So you can actually, when you look at things, like this was my favorite thing to do during COVID lockdown. It really was. I absolutely loved it because like there's so many studies and stuff coming out. And I was reading them and I was looking for this stuff. Like, how are they getting these numbers? How are they doing the thing? How confident were they? And a lot of these, they weren't confident at all. Like, their numbers were all over the place. But what the politicians looked at was, well, your high number is good. So your high, it could be 95% effective. We're going with it. Like that's what they were doing, even though the numbers were like from like 60 to 95, it could be. So that's where they were using that concept for. So it's like, yes, you can start to play with the numbers, but that's what a confidence interval really tells you. It's like, I don't know where it is. I just know it's somewhere between here and here. Okay. So we're going to get into more of that next week with the hypothesis testing. All right. We are done. Sure.
Professor,
What is
like
the problem?
X
Hold on one second.
What is the problem